Now here we want to integrate 1 over x squared times the square root of 1 plus x squared. Now the idea here is to make a trigonometry substitution, and I'm going to go ahead and substitute that. Okay, so I will start by saying let x be equal to tangent of theta. Alright? So by making x to be tangent theta, it means that the x is going to give us secant of square theta d theta. So this is the substitution by making a tangent trig sub. Okay, and by differentiating that, I'm going to get secant square, and I just put down the theta. So that means that in place of x, we're going to have tangent theta, and in place of x squared, we're going to put it down as tangent of square theta, and in place of dx, we're just going to write secant square theta d theta. Okay, so this is going to give us 1 over x squared, that is tangent square theta times the square root of 1 plus tangent of square theta, then dx we just put it down as secant square theta d theta, right? Okay, so this is what we get from the trig sub, or from the change of variable from the x variable to the theta variable. And here we can just do some simplifications. We're going to enter with 1 over tangent of square theta times the square root of, well, I believe you know that 1 plus tangent square theta is secant square theta as an identity, alright? Secant square theta, and here we can just write it as, okay, let me bring it up. We're going to have secant square theta and put down the theta like this. Now again, we can cancel out some things, knowing that the square root of secant square theta is going to remain just secant theta, because the square root will take care of the square, right? So the secant theta can cancel one of the seconds on top. We're going to enter with just a single secant theta, okay? And the denominator will just have tangent square theta, and we just put it down the theta like this. Alright, so over to this part of the board. Well, the trig identities for that, secant is the same thing as 1 over cosine. So I'll just put it down 1 over cosine theta. And, well, we have times 1 over tangent square theta, right? Tangent square theta, I'll just put down the theta like this. And again, 1 over tangent square theta is cotangent square theta, and cotangent square theta is just the inverse. So we can just swap things. We're going to have the integral of 1 over cosine theta times 1 over tangent is the same thing as saying sine square theta over the cosine square theta. So you see that this will just be turned upward because of that is just invertible. So we will talk about 1 over cosine theta times cosine square theta over sine square theta, and we just put it down like this. Okay, again, cancel some things. Cosine theta will cancel out with one of these, and we will just have the integral of cosine of theta divided by the sine of square theta, the theta. And this is now a simple something to deal with. Right? We can do this by making a use of. Here I made a trig sub. So by making a use of, I'm going to say let u be equal to sine theta. Alright? Let me just use blue ink. So let u be equal to sine theta. That means that du is going to give us cosine of theta d theta like that. So if that's the case, then our integral will now become the antiderivative of, okay, 1 over u squared. You know that u is sine theta, so if you square sine theta, you're going to have u squared. Just like when we squared tangent, when we took x squared, it was now tangent square theta. So that means 1 over sine square theta is the same thing as 1 over u square times, now cosine theta d theta is just du, like this. Alright? So by integrating this, we're going to have the integral of negative 2 plus 1 divided by the new power, negative 2 plus 1. So from here, we can just have it to be negative of u minus 1, right? Well, u is the same thing as saying sine of theta. So in place of u there, I can just put down sine theta. So we just be having sine theta, and we raise that to the negative 1 power. That follows that, well, let's just add an arbitrary constant to this. So from here, it follows that negative 1 divided by sine theta plus c. Alright? Very nice. Okay? Now, we can still do some more work on this. Remembering that we started with the x variable, so we need to arrive there, right? So what was our theta actually? Well, recall the original the first substitution, where we're having that x is equals to tangent theta. That means that theta is going to become the tangent inverse of x. But let me not go to that. Now, since x is equal to tangent theta, if we have something on a right angle triangle, let me consider that. Then we have this to be our angle theta. This is the right angle. Then tangent of theta is equal to x. We know that tangent of an angle is just opposite over adjacent. So where the adjacent here is 1, because the denominator of x here is just 1. That means that the hypotenuse side is going to become x squared plus 1, alright? And to get sine theta from there, sine theta is going to be opposite over hypotenuse. So that is going to become negative 1 over opposite x over square root of x squared plus 1, and we just add a c with that. So by inverting this, we'll be talking about square root of x squared plus 1 divided by x and the negative of that, and we just add an arbitrary constant. So that right there is the antiderivative of the given function in terms of x. So let me write it properly. So this is equal to negative square root of x squared plus 1 divided by x. I can just put the c here, and that makes some sense. Okay, thanks for watching.